Hello everyone, I welcome you to my videos. The topic for today is Introduction to Non-Conventional Energy Resources. First of all, let me ask, what are non-conventional energy resources? Are you thinking? Okay, let me show you what we'll be covering. Introduction to energy. We should be aware about what is energy, the conservation of energy, and the types of energy resources. Then we'll be covering with solar energy, wind energy, tidal energy, hydro energy, biomass energy, and geothermal energy. We all know what is energy. Energy can be defined as the ability or capacity to do work. There are different forms of energy from which energy can be obtained. It may be in the form of chemical energy, which is due to chemical reaction, electrical energy due to flow of electron, heat energy, which is due to the thermal vibration, light energy, we know it is due to radiation of the light, mechanical energy due to moving parts, and nuclear energy due to nuclear reaction. The unit of energy is joule or newtons per meter. What does the law of conservation of energy states? It states that energy can neither be created nor destroyed, but one form of energy can be converted to another form. Here are some examples which are covering the law of conservation of energy. We know that a battery generates electrons from chemical reaction, which are used to make electrical energy. So, one form of energy can be converted to another form. Next example shows how a heater converts electrical energy into heat energy. The human leg converts the chemical energy stored in muscles into mechanical energy when you pedal a bicycle. There are broadly two categories of energy resources depending upon the basis of the availability. First of all, primary energy resources, and second is secondary energy resources. Primary energy. All energy originates from natural sources such as coal, wind, hydro. All these resources are primary energy resources which are available directly. What are secondary energy resources? The energy converted from primary energy resources. For example, solar energy can be converted into electricity. So the things which are available directly like coal, solar, wind, hydro, which don't need conversion, these are primary, and which needs 2 to 3 steps to get converted into another form of energy. These are the secondary energy resources. Now, type of energy sources. We know there are only two: conventional, or we can say non-renewable, and second, non-conventional energy resources or renewable. Our main target are non-conventional energy resources. What is conventional energy or non-renewable energy? We know conventional means which is going on usual, and non-renewable which cannot be renewed, which cannot be replaced. So conventional or non-renewable energy resources are those which cannot be replaced continuously. Generally, non-renewable energy sources come out of the ground as liquids, gases, and solids. For examples, they are coal, oil, petroleum, natural gas, nuclear energy. Non-conventional energy or renewable energy. Renewable energy is a source of energy that can never be exhausted, can be replaced continuously. We can obtain renewable energy resources from the sun, from the water, from the wind, from crop residues and waste. The type of non-conventional or renewable energies are tidal, hydro, biofuels, wave power, solar energy, wind energy, biomass, and geothermal. Let's come into the details of all these energies. First is solar energy, which comes directly from the sun, which means it is a renewable source of energy. We can use the sunlight to create pollution-free electricity. The solar cell is a system used to convert the sunlight energy into electrical energy. These are the solar collectors. I wish you would have observed it at the traffic signals. This is called a cell. Cell is in the shape of a hexagon, then a module and an array. The basic resource for all solar energy system is the sun. Knowledge of the quantity and quality of solar energy available at a specific location is of prime importance for the design of any solar energy system. Thereby, we can see that is available in South America in the southern region, North America also in the southern region. In Africa, in the northern regions, India is also getting covered, then Australia and the lower region of the south of Africa. Although the solar radiation is relatively constant outside the Earth's atmosphere, local climate influences can cause wide variations in available radiation on the Earth's surface from site to site. In addition, the relative motion of the Sun with respect to the Earth will allow surfaces with different orientations to intercept different amounts of solar energy. It is the primary task of the solar energy system designer to determine the amount, quality, and timing of the solar energy available at the site selected for installing a solar energy conversion system. Tidal energy is the energy due to water waves created in the ocean. The tidal energy is also called hydropower. We all have seen the raising and the falling of the waves, which are used to rotate the turbines, and hence electricity is being produced. This is the wave energy. You can see over here how this works. This is the turbine. The water comes in and we take it in the basin, and a process we'll covering in the later lectures how it's going on. Then again, after when there are low tides going out, then again it will rotate a turbine and we'll be getting electricity. So this tide electricity generation works as a tide comes in and again when it goes out. The turbines are driven by the power of the sea in both directions. Turbine rotation due to tidal energy, you can see how actually the turbine rotates. Wind energy is a kinetic energy associated with the movement of atmospheric air. Wind energy systems convert kinetic energy to more useful forms of power. Wind energy systems for irrigation and mining have been used since ancient times. We know Holland, where the tulip farming is carried out by using windmills. So this is the wind energy. Wind is simple air in motion. Wind is caused by the uneven heating of the Earth's surface by the sun. During the day, the air above the land heats up more quickly than the air above water. The warm air over the land expands and rises, and the heavier, cooler air rushes it into the takes place, creating winds. These winds are used to rotate turbine blades, which spins the generator to produce electricity. Here, the process has been shown. So, cool air over the water moves in, and it's faster than water, and the warm air over the land rises. And these are the windmills which I was talking about, if anybody has seen in the Holland. Hydroenergy. Hydroenergy is derived from flowing water in rivers, water streams in mountains, or from man-made installations where water flows from the high-level reservoir down through a tunnel and away from the dam. A dam is built to trap water, usually in a valley where there is an existing lake. Water is allowed to flow through tunnels in the dam to turn turbines and thus drive generators, and the electricity is produced. Example, if you have seen the Bhakarnagal Dam in India. This is the inside of the hydropower plant. This is the dam. This is the reservoir. The water is stored in the reservoir. This is the intake. Then this is the control gate, which is open or closed as per the requirement. Generator is placed over here. These are the transformers, powerhouse. These are the power lines. So the water is taken from the reservoir. It goes through the penstock. It rotates the turbine. The turbine when rotates, it causes the generator shaft to move, and hence the electricity is produced. And this is the outflow. Once the water is used, it is left into the river again. This is a typical hydroelectric dam, if you can see. These are reservoir, penstock, turbine is rotating, generator is there, the power lines are getting the electricity, and this is the outflow of the river. Biomass energy or bioenergy is energy stored in non-fossil or organic materials such as wood, straw, vegetable oils, and waste from the forest, agricultural, and industrial sectors. So we burn fuel, we take heat water to make steam, then steam turns the turbines turn to generators, electrical power sent around the country. So with this, we come to the end. These are the examples. With this, we come to the end of the lecture. Thank you for listening. Have a good day.